There are three types of volcanoes: shield, stratovolcanoes, cinder cone. They are composed of different materials. Each volcano type and eruption style varies with the plate setting, and each is a different size. Shield volcanoes. For example, in the Hawaiian Islands, they're broad, they have gentle slopes, built from many low viscosity lava flows. They have relatively mild eruptions that are associated with hot spots, divergent plate boundaries. Stratovolcanoes, for example, Osorno in Chile, is the most common volcano type. It has steeper slopes built from alternating layers of tephra and medium viscosity lava. They're made out of andesite. They form on plates that override subduction zones at convergent plate boundaries. Cinder cone volcanoes are the smallest volcanoes. They rise up to 400 meters in elevation. They are built from more viscous magma products, very coarse tephra. They may form on slopes of shield or stratovolcanoes. Sunset Crater volcano in Arizona. Other volcanic landforms, a caldera, such as Yellowstone. A giant crater formed from the collapse of a volcano into underlying magma chamber, for example, Yellowstone, Wyoming. The brown represents the basalt flows. Other volcanic landforms, a lava plateau. Hundreds of low viscosity lava flows stack up on top of each other. The individual layers of basalt can be 10 to 20 meters thick. A plateau is thousands of meters thick. It forms from some of the largest volcanic eruptions, the Columbia River Plateau. A lava plateau. See where they're located, all these red areas around the world. A massive basalt eruptions formed lava plateaus and elevated atmospheric levels of carbon dioxide from 120 to 800 million years ago to produce global hothouse conditions. Geysers, hot springs, fumaroles, and mud volcanoes. These form whenever water circulates near a magma chamber. Geysers, and the most geysers in the world are located in Yellowstone Park. Geysers are when water is heated under pressure with volcanic gases. A hot spring is heated groundwater rising to the surface. A mud volcano is chemical reactions converting rock to clay. A fumarole is when volcanic gases escape in the absence of water. The thickest crust found below mountains along convergent plate boundaries. The Himalayas, 70 kilometers thick. The Andes is up to 60 kilometers thick. and normal crust is about 40 kilometers thick. The higher, younger mountains are along the present convergent boundaries, for example, the Himalayas. And the lower, older mountain belts represent ancient convergent boundaries, for example, the Appalachians. The Appalachian mountain chain is far older than the Rockies. Why are they there? It has to do with the plate tectonics. Ocean-continent convergence. Continent-continent collision. Reverse faults stack up and thicken the crust along convergent plate boundaries. Additional thickening of crust occurs where the northern margin of the Indian continental crust is wedged below the southern margin of Eurasia. What would happen if we used a block of oak with a density that is 80% of water? Well, density is mass per unit volume. In other words, how many molecules are there in a specific amount of space? The density of water is 1 gram per centimeter cubed. The density of pine wood is half a gram per centimeter cubed. Wood floats because it's less dense than water. The density of pine is half the density of water, so it rises above the water. Half of the pine block lies below the water surface. The density of oak is 80% the density of water. 80% of the oak block lies below the surface. Smaller blocks don't float as high, but they don't extend as far below the surface. Much of the difference in the size of the blocks is in the submerged root. Changes in elevation depends on the relative density of crust and mantle. The height of wood blocks and continents will decrease or float lower as the mass is removed. The height of wood blocks and continents will increase or float higher as the mass is added. The elevation only changes by 20% of the added or removed material. Most changes occur in the crustal root, which is below the surface. The rise and fall of mountains and temperatures. If you remove one layer, the elevation is 16 units. Remove 5 layers, or 100 units, the elevation would be 20 units. This is for oak. If you add a layer, the elevation will be 24 units here. Here's a graph that shows the difference between the region that erodes into the mountains and deep valleys, and the region that erodes almost uniformly downward. For every 1,000 meters of rock that's eroded from the mountains, isostasy results in just 200 meters decrease in elevation. 800 meters of change is accommodated by raising the crustal root. Its evenly distributed erosion causes uniform lowering of mountains. The erosion, which is concentrated in the valleys, can cause the peaks to become higher. Mountains are very long-lived features on Earth. The still-forming Himalayas, that's right, still forming, Mount Everest is growing every year. I'll give you that it's growing only centimeters, but it is growing. The Himalayas began to form about 50 million years ago, and the lower Appalachian Mountains formed about 300 million years ago. The approximate erosion rates are 0.1 to 0.2 millimeters per year. The rate depends on the rock types, the climate, and other factors. It takes 5 to 10 million years to erode 1 kilometer of rock. But isostasy will replace 80% of the erosion. 200-meter change in elevation occurs every 5 to 10 million years. Between 25 and 50 million years to lower a mountain by 1 kilometer. Mountain ranges will persist on the landscape for hundreds of millions of years. The erosion of the Himalayan mountains. Warm, moist air from the Indian Ocean rises over the Himalayas to form monsoon rains, the rain that feeds the rivers that erode the mountains. Sediment deposited in the Bay of Bengal and the Arabian Sea mountains influence climate patterns. The monsoon rains strips the carbon dioxide from the atmosphere. The removal of CO2 has been going on for 20 million years. This action actually reduces the greenhouse gas. And the reduction of the amount of greenhouse gas has lowered the global temperatures by about 5 degrees Celsius. So without this particular greenhouse gas, we would be warmer by 5 degrees. This is showing the monsoons. This concludes Chapter 6, Part 2.